Good day, everybody. Today I will talk about experiments in functional studies of stone tools, and I will devote particular attention to one experiment we performed that relates directly to the topic of this session and that concerns a fire experiment. As is well known, functional studies have a broad potential in identifying tool use. Subsistence activities such as hunting activities or butchering can be identified, but also a range of production and maintenance activities related to woodworking, hide-working, etc. Functional studies have mainly focused on tool use, but also other life cycle stages need to be considered from the moment of production up to discard. And each of these life cycle stages can also result in wear traces and residues. It has been demonstrated that production, hafting, use, reuse, resharpening, each of these can produce wear traces that can be identified, but also residues can be deposited and need to be distinguished. This implies that for a reliable functional analysis, we need to understand the traces and the residues from each of these different life cycle stages. And in order to do so, experiments play a fundamental role. In functional studies, interpretations are made on the basis of analogy. This means that we compare the experimental wear traces that are produced with archaeological traces in order to be able to interpret that. In order to allow a reliable analysis, this requires systematic and repetitive experiments that can build up an entire reference collection. The main research questions for these kinds of experiments are how wear traces form, the different causes and how to distinguish them, but also to translate this to a potential for archaeological assemblages. In the same way, we also need to examine how residues are deposited and how they gradually transform, which ones are preserved, and how this may bias what we see archaeologically. These kinds of experiments are thus mainly focused on methodological issues and require systematic control of different variables. We also have another kind of experiments that more focus on understanding technologies, on understanding tool use in a broad sense, and that try to push the boundaries of interpretation for archaeological assemblages. These kinds of experiments focus on an other range of research questions and can focus on understanding a particular technology, such as hafting technology or projectile technology, and reflect on how to identify projectiles adequately or whether it's possible to identify propulsion modes. This implies that we each time have to evaluate which parameters have an influence and how these can be characterized. Such experiments are thus different from the ones I mentioned previously and are specifically focused on archaeological issues. It means that such experiments are often large-scale, as different phases are required in which different technical choices are opted for and evaluated in terms of the issue at stake. Again, this requires a systematic control of variables, which variables are important, how many, and what would be their influence. This brings us to the issue of control in experimentation, which is an important element. In that perspective, actualistic and machine-based experiments are often opposed. The two kinds of experiments that I referred to previously are independent from this kind of division. But often machine-based experiments are presented as the experiments that are controlled, while actualistic experiments are often presented as if they would not be controlled. But as I just mentioned previously, for each experiment that is performed in the context of functional studies, control is an essential element. And actualistic and machine-based experiments should not be opposed to each other. They're actually complementary. And while machine-based experiments can focus on the link between, for instance, two variables, more on a theoretical level, actualistic experiments permit to integrate this more broadly. So I think it's an important element that control is not purely related to machine-based experiments, as it's independent from the kind of experiment that is performed, and that the combination of both will lead to the most reliable results. At TracerLab in Liège, we've performed a whole range of experiments within the broad context of functional studies. Continuous experimental programs have been going on for a number of years, and experiments have focused both on methodological issues regarding wear traces and residues and the different causes that may lead to their production, but also technologies with a specific attention to hafting technology and projectile technology. This has resulted in a total reference set of over 5,000 experimental pieces that can be considered quite reliable for analyzing archaeological stone tools. Today I will focus on one particular experiment that we performed to evaluate the impact of fire. It's clear that fire and hurt are very important prehistorically. On the one hand, we obviously have fire making that may leave visible traces on stone tools, use-wear traces. On the other hand, fire also plays an important role within the manufacture of tools, not the least for the production of glues, for instance, in view of hafting. On the other hand, fire also plays an important role inside the organization, as a social role, etc. But here, I specifically want to focus on the alterations that are caused by fire or exposure to heat. We can distinguish between a direct impact of fire or an indirect impact. The direct impact of fire on stone tools may create quite dramatic effects with cracks and explosion, the formation of patina, or the removal or transformation of residues. The indirect impact of fire due to heat exposure, for instance, due to the proximity of a hurt on pieces lying around the hurt or underneath the hurt, may also be previous archaeological levels. This kind of indirect impact is less well understood, and this is actually the focus of this presentation. We focused specifically on these fireplaces and their indirect impact on glues preserved on stone tools. This means that we looked at stone tools placed around the hurt, but also underneath the hurt, as the impact on older assemblages, older layers, older archaeological layers has never been really examined. In order to do so, we opted for a range of glue types that we deposited on different stone tools. We looked at sinewy glue, birch pitch and beeswax, resin and beeswax, but also resin mixed with beeswax and ochre. These glues were added intentionally to both surfaces of different stone tools and deposited it underneath and around two different fireplaces for which the temperature was monitored throughout the experiment. 5 different locations were used at a certain distance around the fire, in the fire, and at 2 locations underneath the fire. If we look briefly at the results of these experiments, we can see that in the fire, the effect is quite drastic, of course. The residues on the one hand are completely destructed, all the organic ingredients are gone, while in the case of sinew glue, a very interesting result was obtained. The entire tool surface was patinated due to the contact with the fire, but the zone where the glue was initially deposited was protected against this patination. However, the glue was gone and the surface was entirely cracked if looked under the SEM. In the area around the fire, the effect was different. Glues melted and dripped off the stone tools, but on the other hand, you also had all kinds of incidental charred bone and plant material that were incorporated in the glue remains. This is, of course, a very important element, as it may question certain additives in glues that may not necessarily be intentional. So this should be considered archaeologically, especially on tools that are found in close relation to a hurt feature. Underneath the fire, the results were again a bit different. On the one hand, if we look at glue that was deposited on the stone tool, there was a difference between the surface facing the fire and the surface that faced downwards from the fire. on the surface that faced upwards to the fire, everything was gone. If we look on the face downwards, that was downwards from the fire, the glue was transformed in a microscopically visible thin film of heat-altered resin and beeswax. In the case of sinew glue, it resulted in a complete carbonization of the glue. Another element that was very interesting also from an archaeological perspective is that the residues were lost within the sediment. When we were excavating the stone tools underneath the herd, it was clear that when removing the stone tools that the residues were deposited in the sediment. This is of course an important element for future archaeological excavations. Another interesting observation underneath the fire is the fact that the stone tool was positioned on a piece of wood, and this apparently resulted in the formation of wood pitch and partially carbonized wood tissue on a stone tool on which no such glue was put initially. This interesting result, of course, necessitated a follow-up experiment to test the reproducibility of such incidental pitch. For that, we again used a fireplace in which wood was positioned, and on top of those, underneath and on top of that wood, we placed stone tools in order to examine whether such incidental pitch formed. Again, this experiment proved successful, and incidental pitch was deposited on the stone tools. This implies that the presence of pitch should not immediately be considered as evidence of hafting, as other causes may explain this presence. If we relate this experiment to some archaeological evidence that we've examined recently, we'd like to refer to a quartz stone point that was discovered at Bushman Rock Shelter in South Africa. On that piece, a macroscopically visible black residue was deposited, and it was the question was raised, of course, whether this could be evidence of a hafting glue. Close examination of this residue demonstrated that it was taphonomic in nature and that it was due to a deposition of ash remains. This implies that we have to be very careful with stone tools that are deposited in relation with combustion features, as residues may be linked to the combustion feature and not to the tool use or the life cycle of the stone tool. We thus conclude that the influence of fire should be taken into account when examining hafting glues. In the first place, the heat exposure from fireplaces may explain why we find glue remains so rarely in the archaeological record. On the other hand, degradation or alteration may occur due to direct contact with the fire, but also due to heat from an overlying fireplace, which is an important element to consider. We've shown that experiments permit to monitor the impact of heat and fire on residue deposition and transformation. We also showed that incidental pitch can be deposited on stone tools under specific conditions, which is a factor that should be considered more closely in the future. This permits some general conclusions. In the first place, experimentation is an essential part of functional research, and different types of experiments are useful in the framework of functional studies. Actualistic experiments are not less controlled than machine-based experiments, and both are complementary. If we look at the kinds of experiments that are performed, we have two kinds mainly, independent from whether they're actualistic or machine-based. Experiments that are focused on more methodological issues and experiments focused on archaeological issues. The methodological ones focus more on issues as wear formation or residue deposition, while the more archaeologically oriented ones focus more on life cycle stages and insight in prehistoric technologies in a broad sense. Thanks a lot for your attention.